Thank you for joining us and welcome to our fourth webinar in our series, Integrating Dynamic Modeling and Simulation into Your Courses. In this series, we feature experienced professors from various fields who share their insights on incorporating dynamic modeling and simulation into their coursework. Our goal is to provide you with a starting point and direction to begin implementing these techniques into your own teachings. Today's webinar is presented by Dr. David Wheat and will focus on introducing dynamic modeling effectively and macroeconomic courses. But before we begin, let's briefly review some webinar mechanics. So you will see a grab tab on the side, and this is important if you're having any audio settings to check the audio panel. That will be the location you can help figure out and troubleshoot. And the really important area is the questions box on the bottom. We will have time for a Q&A at the end of this webinar, so please type in your questions there for us. Now, let me introduce you to today's presenter. Dr. David Wheat has over 25 years of experience teaching economics and dynamic modeling, not only in the US, but Norway, Ukraine, and Lithuania as well. He has worked as a macroeconomic modeling expert for banking organizations and was employed by the White House. He was an editor for the book Feedback Economics and is working on his second edition of his book Useful at Macroeconomics currently. We are delighted to have him today.
Thank you very much, Hillary. I really appreciate the opportunity to speak to everyone today. It's unfortunate that a webinar doesn't give us the opportunity to have the eye-to-eye contact and the other kind of personal interaction that makes teaching and learning so effective. But I really appreciate what the IC Systems people have done to put this together, and I'm glad to be here. The notion of teaching macroeconomics with system dynamics obviously depends on the level of the instruction, the type of courses. I'd like to begin just very quickly to tell you about the types of courses that I teach, and then I'll focus on one type for today's presentation. And then I will spend just a few moments on the whole motivation for getting involved in this many years ago. You know, why I decided that system dynamics was the best tool for learning macroeconomics. And then the bulk of today's presentation will actually be a kind of a walkthrough of the entire course that I teach in Virginia these days. And some of that will be fairly general, but then some of it will be down to the nitty-gritty, so you'll know what students are actually doing. And then as time permits, I'll say a little bit at the end about some coming attractions, things I'm going to be working on in the coming year. So here are the courses that I am currently or have been teaching recently, as Hillary mentioned, both in Europe and the United States, Bergen, in Ukraine, Lithuania, and a small college in Virginia. So I teach a course called Model-Based Economic Policy Design in the fall semester in Bergen, and that course will actually utilize some of the material in this textbook, Useful Macroeconomics, that Hillary mentioned. But that focus is on a graduate level, and those students already have quite a bit of modeling skills when they get to the classes for second-year students in the Bergen Master's Program. So the orientation is a little different there. Since 2012, I've been teaching courses at Kyiv Mohyla Academy and also University in Lviv in Ukraine. And those courses, one's in the fall, one's in the summer. I've got one coming up in about a month. Economic Dynamics is a fall semester course, and Dynamic Macro Analysis is a short summer session for those who have already taken other courses that I've offered. For many years, I taught a monetary policy course at ISM University of Management and Economics. Unlike these other courses, that course was very intensive in a 4-week span, and I always was physically present in Vilnius for those courses. And just in the last year or so, I've decided to give that up. And so that's no longer on my active list, but I really enjoy teaching that course and integrating system dynamics with the study of monetary policy. And then a course that actually goes back to the late 90s and was part of the motivation for getting into this way of teaching macroeconomics is a course I offer in Virginia, the community college called Virginia Western in Roanoke, Virginia. And some of you might think of it as sort of Macro 101, but it's typically called Principles of Macroeconomics in the US. And I teach that every semester, usually 2 or 3 sections, one in a live Zoom lecture setting, and then I record that lecture and share it with the asynchronous courses, the asynchronous sections that I also teach. So that's today's focus, that undergraduate course. So a little bit about the motivation for getting into this. Back in the late 1990s, I was a full-time consultant working with some banking clients in Virginia, and a telephone company, and a public policy think tank in Washington, and had a variety of clients. And I was invited to be an adjunct professor at the community college at Virginia Western. And I walked into this macro course, and it didn't take me long to realize that the students were totally lost. Maybe that's because of the way I was teaching, because I was fairly new to that at the time. But I really concluded that the way that textbooks were organized and the use of static graphs really provided no continuity for learning macroeconomics, and the students tried to memorize as much as they could, but I could tell that they really weren't internalizing everything. So I took one of my consulting skills, which was system dynamics, and in those days I had been self-taught. Really, I had been exposed to SD back when I was a graduate student at Harvard in the 1970s, when Jay Forrester and his team were working on urban dynamics, I believe was the project that was underway at that time. So I knew a little bit about it, and had picked up software and tried to learn it myself, and probably knew just enough to be dangerous. But it did serve its purpose in my consulting business, and led me to create the first version of MacroLab to use in the community college course. And I was really delighted at how well that was received. And so I sort of had my mission, my new professional mission in life, you might say, to teach macroeconomics with system dynamics. But to do that, I felt like I needed a proper education. So at the age of 55, I moved to Bergen, Norway, and met all my good friends and future colleagues there, and got a PhD, and with the focus on using system dynamics to teach macroeconomics. The whole time I was doing that, especially the first few years that I was teaching in Bergen and teaching online to students in Virginia, I found myself constantly pulled in 2 directions. One, for academic purposes, I felt like I needed to make MacroLab a little more sophisticated, you might say, and deal with bigger, more challenging questions. But at the same time, I felt that I needed to stick to my original plan, which was to provide an accessible way for students at the very earliest stages of their economic studies to use some sort of dynamic modeling. And I finally got back to that in the last few years. I did get a lot of encouragement from colleagues along the way, and everywhere that I've taught, I've had the academic freedom to teach macro my way, and without that, I don't think I could have accomplished nearly as much. I came back to the U.S. early in 2018 after retiring from my position, full-time position in Bergen, and then pretty quickly got involved in another book project with some friends, Bob Cabana, Brian Dangerfield, Oleg Pavlov, and Mike Radzicki, and we edited the book Feedback Economics, which has actually been quite a popular book that Springer has published. And then that book actually led to the development of a workshop that I've conducted at the System Dynamics Conference almost every year since I've been back in the States. And that workshop is basically how to get started with macro modeling. And that I had a chapter in this book about that, and that was sort of the springboard. And one of the things that's interesting and connected to everything I'm going to be talking about today is that some of the participants in those workshops got really interested in this approach to economics, and they asked permission to audit some of my online courses, particularly the one in Bergen. And some of them audited more than once. And we've developed a kind of a little coffee club that we get together every few months and compare notes about what each of us is doing. But they gave me a lot of encouragement, and one of those who had really a different role in relationship with me for many years was Diana Fisher. And Diana kept saying, you need to write this stuff down. And you know how Diana is. When she says that you should write this down, you take it pretty seriously. So I was thinking hard about that, and just almost out of nowhere, I got a contact from a publisher, Kendall-Hunt, with an opportunity to create a textbook for my undergraduate students. And the rest is history, I guess you might say, because that's what led to Useful Macro. So let me say just a word about the orientation that I have to give to these students at the very beginning of the course. They're new to macro. They've never had probably any economics course before, and they definitely are new to system dynamics. So I try to set them up maybe for what I consider to be success early on by tying these two together. And I say that macroeconomics is a study of how an economic system performs over time. Now, since they've never read other economics textbooks and never seen another macro introductory text, they don't know that that's not really the way macroeconomics is taught. So they'll just take my word for it, that it should be studied as a system over time rather than a static topic that's devoid of history. And then system dynamics I just present as a tool for studying the performance of systems over time. So obviously there's an opportunity for a marriage there. Early on, I get them ready to work hard. They have to get their Stella Online license from IC Systems even before the first week of class and start studying the tutorials. I emphasize that knowledge is cumulative, that learning is a spiral process, and they're going to see me coming back to topics week after week after week that they probably thought they were through with, because that's the way that most young college students think about learning, I believe. They fail to grasp very quickly that knowledge is cumulative. I want them to learn some definitions, macroeconomics definitions, but also the definitions that might be expressed in equation form. Learn those definitions, but when we get to hypotheses, tentative theories about way the economy works, I want them not to learn them as in memorizing, but to grasp them, to get an understanding of what I'm saying, and then question them. So I really, and I also emphasize that there are no laws of economics. You'll find no economic laws in my textbook, because I think they're all hypotheses. And once we get past the narrative and start writing equations, then I distinguish, and I want them to know the difference between identity equations that are true by definition and behavioral equations, which incorporate various hypotheses. And I flag those in every chapter when we're building different portions of the full model. I introduced MacroLab Lite, which is the featured model economy for the textbook, as a flight simulator. They seem to warm up to that idea, and that what computer modeling is nothing more than taking our ideas and converting it into information that can make the simulator fly. I don't want to get too technical at the beginning, but I do jump right into the building blocks of SD with stocks, flows, and feedback loops. And all the time I'm talking about computer modeling, I keep reminding them that it's a tool for building something much more important, and that's their mental model. I want their mental model to be able to enable them to see the economy performing as a system. So this is the table of contents on the right-hand side of Useful Macroeconomics. This is the second edition table of contents, which adds chapters 9, 10, 11, and 12. And I'm not going to say much about that now because I'll come back to these separately. But I'd like for you to see that this actually provides a sequence for the whole course. The first part is the economy as a system, and I cover a lot of historical ground, and I want them to sort of have a sense of the basic tools of SD and start thinking about how things fit together, but not much detail in those first three chapters. Part 2 is about the supply side of the economy. Part 3, the demand side. And if you look at the cover of the textbook, that little circle, which is sort of a, I guess, reminiscent of a feedback loop diagram, although it's not really drawn that way. But I'm tying together not only the systems thinking and modeling, but also I'm tying that together with the economic history, and particularly the history of economic issues and data literacy. Those are the 3 main themes of the textbook. Every chapter is divided roughly a third between a third and a third and a third with each of those topics. And as you can see from the table of contents, each chapter covers a different time period. So I have a couple of very high-level learning goals. And I think if I have just a few learning goals, it's much more likely students are going to be able to achieve them. But they're pretty critical, I think. So I want the students to learn what I call the characteristic behavior patterns of key U.S. economic indicators, and to grasp some plausible hypotheses for those patterns. And the key indicators are prices and inflation, unemployment, and economic growth. Every chapter begins with a graph just like the one you see on the screen. The difference that you'll see from chapter to chapter is we move through different time periods. So each, especially once we get up to 1950, we cover the first 190 years pretty quickly for U.S. history. Then we take quite a long time to cover the rest. And each chapter covers a 10-year period. So as we get into that chapter, we discuss the issues, the economic issues, and relate that to concepts that they're studying today and hearing about today. And that, they discover that things have been even worse in the past than they were a couple of years ago, at least with respect to inflation. And so each week we move through a decade, and all the time we're revisiting these key economic indicators. Of course, we look at others as well, but these are the 3 that we might call the headline indicators. So what we see in this graph covering the period from 1950 to 2030, well, obviously not 2030 yet, but to this decade, prices are rising year after year. Usually the inflation is moderate, but sometimes it's quite high. The unemployment rate is like a roller coaster, and it's an uneven roller coaster. It's not uniform. What's kind of interesting, though, if you go back and do the math, that every decade has an average unemployment that's close to about 5%. That's really, really hard to see in the data, but that's kind of the way it works out. So that's a curious behavior pattern, I think. Now you've got per capita economic growth is our measure of economic growth for the course, and it's steady on average, and I say here until it's not. And then we see that the bottom drops out, it seems like maybe about once every decade. So I want them to get so familiar with these indicators that they could, describe what's going on in the economy over time, not by particular years necessarily, but just describe the kind of patterns that are emerged from the economy. Remember, this is a first-year course, and I think you have to set your expectations accordingly. But not just learn them and remember them, but start asking why. And then what I want them to see, and I'm sure, I'm confident that they will, the way the course is taught, is that answering one of these questions is very closely related to answering the other. So these answers are interrelated, just like the structure of the economy that produces this behavior is interrelated. And that's part of the method to my madness when I keep emphasizing the way that these patterns develop. The second learning goal will be that the students learn that the economy is a system, and its behavior patterns result from the interaction of its interdependent parts. I'm not sure if interdependent needs to be hyphenated or not, but I do know that when I don't hyphenate it, students read too fast and they think the word is independent, which is exactly the opposite of what interdependent means. So the hyphen is there for a purpose. So they first get a look at the model with this very simple little picture of a demand side with the spenders and their bankers, and the supply side with the producers. And then gradually, chapter by chapter, they begin to get a little bit more detailed picture. But this gives a fairly high-level view of the MacroLab Lite model that is the featured model in the textbook and we use in the course. So you see a supply side with 3 submodels. You see a demand side with a few more submodels. And then you see a flow of funds submodel that sort of ties it all together. And we'll study these submodels usually in one chapter as a standalone submodel. And then we want to be able to bring it back. When I mentioned the middle part of the presentation, the teaching strategy portion of today's presentation, I emphasized the idea that the patterns and the trees and the forest is kind of an important little metaphor running through everything I'm doing. I'm very mindful of the possibility that students might spend so much time inside one of these submodels and with all the details that they get lost in the trees and they forget the forest. And so everything that we do is to try to keep them aware of both. So let's quickly run through the weeks of the course. You'll get an idea of what we're doing, and then I'll focus more closely on just a few key points. So the first 3 chapters cover, as I said, a lot of ground, and the emphasis is on inflation, on employment, and GDP, the measurement of those variables, in the case of GDP, how it got invented during the Depression years. Students have probably more difficulty with the concept of inflation and the distinction between inflation and prices than just about any other concept. They can't fathom how inflation could be going down if prices are still going up. And we spend a lot of time on that issue. And I show them this graph, and they actually have a little modeling assignment where they can see what's happening and they can play with the parameters of the model and get a sense of why it's happening. So in the first 3 weeks, the modeling is more of an introductory task, and so they get their introduction to stocks, flows, and feedback. I emphasize 1,000 times and one more time than that inflows add to stocks and outflows subtract. And if they remember that, they'll be able to decipher most any feedback loop diagram that they see, or excuse me, stock and flow diagram they see. And then they get an introduction as well to feedback loop diagrams. I don't use the term causal loop diagramming. I think that in the economics world, feedback loops is something that's fairly commonly heard, even though few economists actually work with them. So I use that term. I also use the terms positive and negative feedback loops rather than reinforcing or balancing. I think that's more commonly understood in the economics field. This little diagram that shows the population model is one of the first that they get a chance to play with and build. And I emphasize that the feedback loop diagram is something that's a communications device. It helps you communicate something that's a little more complex, namely the stock and flow model, and that the feedback loop diagram should be consistent with the stock and flow model. I also depart a little bit from convention, at least from the standpoint of system dynamics modelers, in that I don't use pluses and minuses to indicate positive and negative. I think my students would have difficulty finding all the pluses and minuses sometimes, even though they're on the diagram. It's easy to overlook them. So I use the dashed arrow in Stella, the connector, and that represents the negative link in a loop. Then the simple modeling assignments they've had, or they will have in those first 3 weeks. One of them takes us back to the cover of the textbook you saw a moment ago, and you can see here a pattern of business establishments opening and closing in the U.S. over a 40-year period from late 1970s. And so the blue curve is the inflow, the red curve is the outflow, and the black curve is the stock. And so the students can begin to see that whenever the blue curve is higher than the red curve, the stock is going to be rising. And then if the reverse is true, the stock will dip. And there are 2 or 3 points along that 40-year period where the outflow is greater than the inflow. More businesses were closing than opening, and that's evident in the behavior of the stock. This is one of their first modeling assignments, and to build a simple savings account model. Typically, when I want them to build a model from scratch, I will provide it in this format. So I give them a model diagram, both in stock and flow form and also in a feedback loop form. I give them the equations that they need, and I show them the behavior that they should expect to get. Another important byproduct of this little assignment is it introduces students very quickly to the idea of simulation experiments. So we have 2 runs with different interest rates, and I emphasize that that's an experiment to see what happens when you change the model a little bit. Chapters 4 through 6 will focus on the supply side submodels, the production and sales submodel, labor and productivity, wages and prices. We're going to take a look at labor and productivity in more detail a little bit later. After the first 3 weeks, first 3 chapters, the students will start building these submodels. But in order to make this task a little bit less tedious for them, I'm trying to make it a little bit entertaining by calling it a jigsaw puzzle assignment. And you'll see what I mean a little bit later on, where they have to put the model together like you would put together a jigsaw puzzle. And then in week 7, I tie all the supply side submodels together, and we can simulate that. But I go further and create a fairly simple demand side, which is not the full MacroLab Lite demand side yet, but I call that the midway model. And you can see the red links there is where the 2 sides are tied together. And you can play with this model online. You can see the link up at the top. And the model runs in 3 modes right now. It runs at unbalanced growth, which is the more common and realistic growth, so that everything is a little bit unpredictable. Not necessarily random, but nothing is set in equilibrium to begin with. And it's not like balanced growth where you have the same and constant growth rates all the time. But it will do all 3 of those. And there will be a historical mode before too long. This is the interface that you'll find online, and you can play with the model to your heart's content. And also click on Tutorial 7 button and read a little bit about this model. Chapters 8 through weeks 8 through 13 will focus on the demand side submodels, and this is where you get to take a close look at the spenders in the economy and their bankers. And I put a heavy emphasis on the role of banks in this textbook. I think that's critically important to understanding the way that the economy grows and the use of credit. So that's one of my sort of theoretical ideas. That it's not an original idea. A lot of other people have used that in their modeling work. Steve Keen is probably the one who's most well known right now for emphasizing the role of credit as influencing aggregate demand in addition to the income. The simulations that we would do again would be kind of an isolated form, just like we do on the supply side, and then I would tie them all together for the demand side submodels interacting, and they would use jigsaw puzzle assignments again. And then finally, the last 2 weeks of the course, the full MacroLab Lite has come together, and that's what you see on the left-hand side of the screen, and the right-hand side is the interface for the online version of the model, which also includes some policy testing. Okay, now I want to focus on what I consider to be the challenge, and that's this patterns, trees, and forest idea. So when the students study one submodel at a time each week, which is the standard procedure, there's a risk. They're close to the trees, and they may lose sight of the surrounding forests. So I've designed the pattern of work to try to minimize that risk. And this is our typical weekly procedure for submodel analysis. So they receive instruction about a particular submodel and its components, its macroeconomic components. They see that in the textbook, the chapter they're reading. they view a lecture either live on Zoom or a recorded version later, and they study the slides for that lecture. And they study a tutorial online, which is developed using the Stella storytelling feature. And then they build and simulate the submodel in Stella Online. So each student has a free account, and I design these submodel tasks so that they're within the parameters set for Stella Online, and that's what they do. So this is a typical procedure. They're learning about the trees when they do this. So they're learning about one submodel at a time. But when this is over, when they finish this particular task, then I will have them compare. I will provide them access to behavior patterns of, let's say the unemployment rate, a key variable in the submodel they've been studying. And we're going to look at that particular variable and how it behaves under 3 different types of structure. The first would be the isolated submodel, the one they've been building. And then what happens to that variable when that submodel is connected to all the others nearby, which in this case would be all the other supply side submodels if we're talking about the labor and productivity submodel where the unemployment is determined. And then finally, we'll link the supply side and demand side together. So we got the full model operating, and we replicate the experiment again with that structure. And then what they see is different behavior. And they need to speculate on why that behavior differs. And eventually I will provide some brief explanation. But the purpose of this is to remind them about the forest. And in the case of, if they're early in the course, they're learning, say in chapters 4, 5, and 6, they haven't really even seen the full model yet, or the other submodels. So it gives them something to look forward to. So hopefully that I can present this in a way that motivates them to wonder why the behavior is different when we take this submodel, which is simple and pretty easy to understand, and connect it to everything else in the model. Now on the next page, or next couple of pages actually in this presentation, I want to show you what they actually do. So I'll show you how the jigsaw puzzle modeling task works. And also I'll show you the way that in that particular example, the comparison behaviors are generated. So this is the student modeling task with the labor and productivity submodel. So that they receive this jigsaw puzzle, and if you're familiar with Stella and Stella Online, the icons are the same in both. If a variable or parameter is undefined, you get this little warning sign in the middle, and you see most of these are undefined. A few cases I've already written in the equation, or I've written in a parameter to begin with. And I think in this particular case, the only thing I've written in was the parameter for depreciation rate and the real AD growth rate, which has a step function in it as well. In order to abide by the requirements or the limitations of Stella Online that can only be 3 stocks, I took the labor force data stock and I made some artificial data out of it based on the growth rate that we would have used in the simulation. So we can treat labor force data on the left-hand side as something is given as well. So they're given the jigsaw puzzle. I send them a model. They can open it up in Stella Online, and also I provide some slides and text that gives them a list of equations. And I show them a picture of what it should look like, and this is what it should look like. So it's pretty impressive to me that these students who have never even done this at all before can typically get it done and do it right. And most of the mistakes are really silly things, like making failing to make a good connection between a stock and a flow, and so nothing is really changing in the stock, even though the flow is working really hard, or making the inflow and out instead of an outflow, or an outflow instead of an inflow. Kinds of mistakes that all beginning modelers make. But the students really surprise themselves at how well they can handle this software and these pretty simple ideas. So you'll see on the far left-hand side of the screen, the unemployment rate is one of the outputs of this particular submodel. So the main input is the real AD growth rate, which actually originates on the demand side, the economy, but we're just doing a partial model test here. And we step up that real AD growth rate early in the simulation from 2.5% to 3.5%, I believe is the number we used. And they make 2 simulation runs and they compare the two. So when they run the model, they get this behavior. The black curve, which is a flat line, is a constant real AD growth rate of 2.5%. If this were part of a full model, and well, in fact, even in this submodel, the stocks are growing, but the employment stock is growing at the same rate as the as the labor force, and therefore the unemployment rate remains constant. But and that's because we're in balanced growth mode when we do this experiment. And then we repeat the experiment, or the students do, on their own, and they step the AD growth rate up by 1 percentage point in year 1, and they see this new behavior. And their submission requirements, their deliverables, they have to send me a link to their Stella Online model so I can take a look at it, and they have to discuss briefly and explain why the unemployment rate was flat in the first simulation and why it declined in the second simulation. And I'm not looking for highly technical explanations, but I am looking for them to use the model, to actually step through the model and see how a change in the real AD growth rate ultimately goes all the way across the page and affects the unemployment rate. So this is the way the student really gets immersed within a submodel, and the risk, of course, is they're so close to these trees that they lose the sight of the bigger picture. So the next thing we do, the next step after this assignment, is to repeat this experiment with 2 other structures. Well, first of all, we repeat it with the LP submodel, the labor and productivity submodel. And then we put the labor and productivity submodel in connections with the other 2 supply side submodels. So the supply side is fully operational, and then we stimulate it exogenously. I don't use the word exogenous in the course, I say external, but exogenously with the nominal AD growth rate. Again, we can make it step up and stimulate the production and sales submodel, and everything starts rolling at that point. And then the third structure is when we put it all together. So now the labor and productivity submodel is part of an entire macro model. In the middle diagram, labor and productivity was just part of the supply side. And in the first case, the labor and productivity model was a standalone, isolated model. So we do the same experiment, or at least a comparable experiment in each case. We let the nominal AD growth rate jump up from 4.5% to 5%. And the inflation, which is also exogenous, coming from the wage and price submodel, is presumed to be constant, so it stays at 2%. And so the real AD growth rate is just responding to the nominal AD growth rate. There's no feedback, there's no output from this submodel that has any feedback effect on anything else that might come back and affect this submodel. So it's totally isolated. And we get behavior very similar to what we just saw when the students built their simple model in Stella Online. And then we go to the second experiment. We repeat the experiment with virtually the same structure, although it's a little bit different just given the nature of the change in the structure, but it has the same effect. The nominal AD growth rate jumps from 4.5% to 5% and remains there because it's on the demand side, and there's nothing to cause that nominal AD growth rate to change anymore after that one-time step increase. This is the supply side forest. So this is a relatively small forest that surrounds the trees that they've been wondering about. And then we move to the third experiment. In this case, we have to do it a little bit differently, but it'll have the same basic effect on the nominal AD growth rate. So in this case, we're in the balanced growth mode again. So everything is rising at a constant rate, increasing at a constant rate, all the stocks are. And suddenly the debt growth rate jumps up from 4.5% to 5%. 4.5% is the debt growth rate that is consistent with the balanced growth. When that happens, that triggers a change in the nominal AD through the equations that are written for how credit is added to income and becomes part of nominal aggregate demand. And it jumps from 4.5% to 5% for nominal AD. But this time, the difference is it doesn't stay there. It continues to change when there's feedback from the supply side to the demand side for the remainder of the simulation run. So unlike the first two experiments, nominal aggregate demand really is a variable, and it's affected by the supply side, and it in turn affects the supply side. And these are the behavior results we get. So the black curve, which is very similar to the results we saw a moment ago when the students built their Stella Online model, we step up the real AD growth rate, and unemployment rate drops and pretty quickly stabilizes. In the second experiment, same increase in the nominal AD growth rate, but now we have a price index that's not constant. Over here, inflation was constant, but now the price is changing, therefore the percentage change, i.e. inflation, is changing, and so the real aggregate demand will not be a constant as it was in the first experiment. And in fact, what will happen is prices will rise a little bit. We still get the stabilizing effect, but notice the red curve stabilizes at a higher level. Unemployment doesn't drop quite as much as it did in the first experiment, mainly because of the impact of higher prices, which reduces the real aggregate demand that feeds into the labor and productivity submodel. And then finally, on the third experiment, we get something that actually, if you'll notice, kind of bounces around the intermediate between these two. If we let this run long enough, it'll eventually stabilize, but quite a long time. And what we're seeing is that both banks, as they set their loan rates independent of the central bank, or I should say maybe in addition to what the central bank incentives are responding to inflation. And the central bank is responding to inflation and unemployment. And the result of this creates really a new effect on the nominal aggregate demand growth that occurred when banks started, when banks were lending more as a result of higher credit demands. So now we have an oscillation that's largely due to the impact of inflation directly on interest rates and indirectly through monetary policy on interest rates. And that would be the quick and dirty explanation that I would give to the students. But I would first ask them to speculate on the reasons that this behavior is different in each of the three experiments. And in the case where they've not studied these other structures yet, I try to plant the seed that we will discover why this is happening when we get there. So let me take about the last minute or so to give you a quick view of the coming attractions. As Hillary mentioned, the second edition of the textbook is coming out this summer, assuming I can find time to finish it. I've modified quite a bit in the first edition to reflect some of the lessons learned in this first year of using it. I've updated all the time series graphs, and as I mentioned earlier, there are 4 new chapters, one focusing on the government sector, and we spent quite a bit of time discussing the whole issue of government debt and deficits and whether it matters, and should we be worried about it for our children and our grandchildren or not. And chapter 10, consumption, income, and expense. The point here is that you can look at consumption from the perspective of households or from the perspective of business firms. And this is the chapter that's about the firms and the households and how intimately they interact. And then we'll sort of step outside our domestic boundary in chapter 11 with foreign trade and look at questions obviously in the news today. And then the new chapter 12 will kind of sum up the whole book, compare this approach to teaching macroeconomics with something the students might encounter if they take further courses, which is probably 1 in 100. But I always have 2 or 3 students out of, let's say, 75 students in a semester who are really, really sharp. I mean, there's one who kept me on my toes all semester this spring with 2 or 3 questions a day, and he's exceptional. So anyway, I want them to be prepared, because they're not going to see aggregate demand, and aggregate supply static curves in this textbook, but I want them to know what they look like. And then my project for the coming year is to provide some resources to supplement the textbook, Student Learning Guide, and Instructor's Resource Manual. I think my intention is this will be more than just a review. I think it'll be a standalone book that will allow people anyone who wants the book can get this learning guide for free, and they can practice and extend their understanding of the modeling. And on the Instructor's Resource Manual, my emphasis is on making it user-friendly for instructors without an SD background, so that they'll be willing to try it. I think I'll skip this last slide. I was going to maybe run through some of the ways that this textbook differs with others. If you have questions, I'll come back to that. And I'll just say, let's wrap it up. And I hope you stay in touch with me. Here's my email, and also a link to the website where I post a lot of material. So thank you for being with us, and I hope you'll get in touch with me if you have questions. And maybe you have some now.
Yes, there are some questions now. So, have students in this class been longitudinally accessed compared to students in higher level macro courses who have taken SD courses and those who have not? This is a very interesting application.
Let me see if I understand the question. Do they perform differently than the students who've already had SD?
I think what they're asking if there's a, oh, John says yes. That's his question, yes.
Okay, well, let me answer the question I think I heard. Yes, they do perform differently. The students who've had system dynamics background obviously have a leg up and are going to be more successful. But I pitched the learning goals a little bit differently for those other courses, the master's level courses. Some of those students have already had some economics courses, and a few those who haven't usually are bright enough to sort of learn it on the run. So I think we get a little more success, out of the graduate students, but that's not surprising to me.
Okay. There are a number of MacroLab versions on the IC Exchange. Do you intend for these to be accessible to students outside of your class? And if so, what versions should we use?
Well, one of the things on my to-do list, which never gets done, is to go back and clean all that up. Because what I would really like to have is the original MacroLab, which was, I guess, came out in, nearly 15 years ago, maybe a little bit longer than that, after I finished my PhD work. That was the first one that was published. I'd like to have that one up there, and I'd like to have the current version, and I'd like to get rid of everything else. And I just need to take some time to go through the IC Exchange and clean it up. And then it should be obvious. I mean, you might want to know what the old one what the original looks like, and you should probably be more interested in the more recent version, which should be the only other one there.
Okay, next question. As you taught your courses and edited and written books, what have you learned about economics that you hadn't previously known? And what surprised you the most?
Oh my goodness. I just wish I could share with students 0.1% what I have learned, which is probably true what every SD modeler says about every client they've ever had. You learn so much more when you're building the model. So I really emphasize that it is a learning tool for the modeler as well. The understanding of the role of credit and the role of money has become increasingly more obvious to me as being so important. I can remember, when I was working in Washington back in the 70s, and that was the period of time when monetarism was challenging Keynesian policies, and I never have believed that monetary policies work because of implementation problems. But that's not the same thing as saying that the basic idea about the impact of money on the economy is something that can be ignored. So I'm probably as strong a monetarist in the, what you might think of as generic sense of the word, as anybody around now, but not for policy, because I think that as we saw in the Volcker era in the 1980s, implementing what the monetarists want to do is extremely difficult. And so I don't think it leads to the same policy conclusions. You might want to control the growth rate of the money supply, but that's beyond the reach of the Fed.
What's the best source for your books?
I'm sorry?
What's the best source to access your books?
Okay, the best source, if you go to my website, you'll find a link to the site for the publisher, and that you can find it there. Let me just say a quick word that is a response to many questions I've had over this past year. The first edition was only available as a rental. So it's an ebook online, and it was geared to a 6-month rental period just for students. And I've convinced the publisher that there's a little bit broader market out there, I think, and that 6-month rental doesn't really satisfy their needs. So the second edition will be offered in 2 ways. One, it will still be offered as a 6-month rental for students, but there will also be a physical book that can be purchased on that website. None of that information is up there yet because it awaits the completion of that second edition. But you can buy that second edition as a physical book if the rental approach is not appealing to you. And anybody who buys the book, I'm going to give away those supplementary materials.
Great. How detailed or technical do you get in explaining the equations in each component?
I explain those that are easily understood. Let's put it that way. So there are times when I'll tell the students basically what an equation does without expecting them to get into it. But almost all of the equations on the supply side submodel task that they have are easy for them to understand. I mean, obviously it takes some concentration, and for many students at that age and experience, that they lack that experience, that concentration. But some of the equations on the demand side, if not complicated, at least there's more detail. And so I really began to move away from the actual modeling about halfway through the course, in the sense of paying lots of attention to the details of the equations. I'm more interested in students understanding sort of the knock-on effects from one variable to the next and how that feeds back to another submodel.
Have you ever been asked by leaders and politicians in varying or any nations to help them learn to create policy based on SD modeling results?
I think I'm sort of operating in a little cocoon somewhere. I'm not sure that anybody even knows I'm doing this. So I guess the answer is no on that. But having worked in Washington, long time ago, I'm still very interested in policy questions. I've recently co-authored a book on policy issues with an economics colleague of mine, and maybe that will stimulate some interest. But as of yet, no.
What are your thoughts about how AI is going to positively and or negatively impact on students' independent thinking in macroeconomics?
I think it will be terrible. My concern is that students will quit questioning hypotheses. If AI says it's true, it is true. I think that the questioning attitude is so important in learning any social science or physical science. You have to be extremely careful for young students. Now, more experienced students, graduate students, scholars in the field, presumably will know how to separate the good and the bad. But I'm really concerned about what it's going to do to undergraduates.
For a non-SD senior corporate leader who wants to become articulate in developing models for our processes, is getting a PhD or something similarly necessary?
Oh, I guess the answer to that would depend on what they intend to do with their new skills. I would say if they're really interested in staying in the business world, a PhD is probably not necessary.
Right.
I might say that when I went to Bergen, I was in the business world. I had my consulting business. I never expected to become an academic, but I had such a warm welcome in Bergen, and I loved working with the students there so much. And I had a lot of freedom to do what I wanted to do. So it was pretty easy for me to give up my consulting business.
Which is interesting because the next question actually ties into consulting. They say your teaching method is inspirational. Do you think this method is equally applicable to working as a consultant?
Equally applicable to what?
Working as a consultant.
Oh yes, I do. I do. I think some of the same, I should say, same concerns and be careful admonitions that everybody should keep in mind as a consultant is that if you're not careful, you can overwhelm your client with too many details and too much complexity. And so you really have to understand the client's question and don't use the client consultant relationship as an opportunity to tell them more than they need to know.
Is SD modeling useful for risk management or risk assessment? Sorry.
I've not used it for that, so I guess I can't comment.
All right, and one of the last questions, I believe, pertains to slide 17. And they asked, how can we know if these feedback loops are positive or negative?
Repeat the question.
How can we know if these feedback loops are positive or negative?
How you mean fundamentally? How do you know that, or how do you know it by looking at a diagram? I mean, in the diagram, you could go ahead.
I was just going to say the question came in when you were on page slide 17, so I think they were talking about something along that.
Okay, I think then it's about reading the diagram. Okay, something I explained early in the presentation was that the convention I use for identifying a link as a negative or positive link is a dashed arrow for a negative link. So anytime you see a dashed arrow, either in a stock and flow model, a connector as it's called in Stella, a dash connector, that's a negative link, negative connector, negative relationship.
Great. That is about all the time we have for questions. Thank you everyone for joining us. And we hope you join us again for our next webinar, which will be in May.
Thank you.